All right, this is section 1.4. This is a review section. So this is mainly going to cover notation, the different types of notation, set builder notation, interval notation, graphical notation. So this is a review. You do not have to watch this if you don't want, but if you feel that you need to go over some of the important notation that we're going to be using, then for sure you want to skim through this. Okay. Now I'm going to go ahead and I'm not going to cover the first page. I'm going to start on the second page. And where you have the summary of interval notation and set builder notation. So you've got the column of set builder notation, which is this, and it looks kind of weird. It's kind of hard to understand, but this is the verbal present. This is how you would interpret it verbally. There's the graph and then the interval notation. So it's a good idea for you to learn these various types of notation because you will be using them at any point from here on. Okay. All right. So first, 8, 9, and 10, they want us to write our answers in interval notation. So interval notation, you can look back up here. So this is what they want, is this column. Okay. Now, the first thing I'm going to do is I'm going to graph because it's really easy to get your interval notation from your graph. So this says that x is less than 20. Now, let me draw this out to the side. So if you have a less than or a greater than, then you're going to use your parentheses. Okay. If you have the less than or equal to or the greater than or equal to, then you're going to use brackets on your number line. Okay. So your parentheses are those. Your brackets are these. Okay. And your infinity symbols always use your negative infinity and positive infinity are always going to be represented with parentheses. Okay. All right. So for number 8, it says x is less than 20. So all I'm going to do is put a mark on the number line, call it 20. It's less than, so that means I want everything to the left with a set of parentheses. So this is what I want. So that's my graphical notation. Interval notation, well, we always write interval notation from least to greatest. Since this is going towards negative infinity, then the smallest that it gets is negative infinity, and we come all the way up to 20. Remember, your infinity symbols always have your parentheses, and at 20, we also have a parentheses. Okay? And so this is our answer because that's what they want is interval notation. Now, z is a real number in between -8 and 10. So we're going to have two numbers, -8 and 10. Now, notice that it says it's between. It doesn't say that it includes it. So that means if it's between these two values, I want all of this, but I have to use the parentheses because it didn't say that it includes -8 and 10. Okay, and so notice what you have. We have a parenthesis at -8, and we go all the way up to 10 with a parenthesis around it as well. Okay, so that one's pretty easy. Now, this is your set builder notation. So it says the set of all x such that -1 is less than or equal to x. Now, this one can be tricky. So another way, something else that you might want to do is to rewrite this and say the set of all x such that. Now, I'm going to flip this around. And when I flip this around, make sure that because it's always easier to have your x first. So make sure that when you flip it around, notice the direction the inequality is opening. It's opening towards the x. So if I start with x then I'm just going to make sure that my inequality opens towards the x. And then there's the -1. So x, it's the set of all x such that x is greater than or equal to -1. Let's scoot this over. So I'm just going to put -1. It's greater than or equal, which means I use a bracket. And since it's greater, I'm going to go towards the right. And then remember, we write our interval notation from least to greatest. So -1, comma, it's going towards infinity. At -1, we use a bracket. And infinity symbols always use the parentheses. And here's your interval notation. Okay, pretty easy. All right, now, when we talk about the union and the intersection of sets, the union of A and B, it's the set of elements that belong to set A or set B or to both. Okay, so basically when you have a union, you want everything from both sets. Now, what this means is, in a minute, we're going to apply this towards our graphs, but and you're going to see how it's, we're going to do something first before we get there. So it's everything from both sets. So union is the greedy one. It wants it all. It wants everything. Okay. The intersection of A and B is the set of elements that are common to both set A and set B. So it only wants what is common from both sets. And so you can see by the Venn diagram, for the union, it's everything in A and everything in B. So it wants it all. The intersection is only where they overlap. That's where they're common. That's that common region. Okay. And then this is very important that you understand this notation. Okay. So the empty set may be denoted by the symbol, and it's a set of braces. This is a braces, and notice how it's empty. There's nothing in it. Okay. So it can be denoted by the set of braces with nothing in it, or this notation, a circle with a line through it. This is not an empty set. Okay. So be very careful. So you can write it one of two ways, either the set of braces with nothing in it or the circle with the line through it. Okay. All right. Now let's look at number 11. So this is where we're going to start to look at the union and the intersection of our sets. Okay. So for set A, we have the numbers 0, 1, 2, 3, 5, and 7. B is 2, 4, 6, 8. C is 1, 3, 5. Now, number 11, it says it's A union B. Okay, so this is a union. Remember, the union wants it all. So the way that we do this is we're going to open our set of braces. So if it wants all of the elements from set A union all of the elements from set B, then we're going to take it all. Now, remember, it says it's either the definition for the union, it's the set of elements that belong to set A or set B or to both sets A and B. So if you'll notice that 2 is common to both A and B, and that's okay because we want all of A and all of B. So I'm just going to put this in order. 0, 1, 2, 3, 4 from set B, 5, 6 from set B, 7, and 8. Okay, so this is your answer for number 11. All right, so it wants everything from both sets. Now, B intersect C, we only want what is common from B and C. So B is 2, 4, 6, 8. C is 1, 3, 5. Now, there is nothing that's common from both sets. So that's going to be the empty set. And remember, we use the set of braces with nothing in it to represent the empty set. It's the set. The set means the braces, and it's empty because there's nothing that we can write that's common. Okay. Now for 13, again, it's A intersect B. So we want what is common from set A and set B. So it has to be the same numbers in A and B. Well, A has 0, B does not. A has 1, B does not. A and B both have 2. Let's see. A has 3, B does not. A has 5, B does not. A has 7, B does not. And then these other values other than 2 are not in set A. So it only has one element, and that's 2. That's the only element that is common to both sets. Okay. All right. Now, find the union or intersection as indicated. Write your answer in set notation and interval notation. So the first thing we're going to do is graph these 3 sets. Okay, so set A is the set of X such that X is less than or equal to negative or to 4. So X is less than or equal to 4. It's a bracket, and we want all of this. Okay. All right. So first we're going to graph, and then we're going to answer 14, 15, and 16. B is the set of X such that X is greater than negative 1. So that's a parenthesis. It's greater, so it's going to go towards the right. And it continues on. C is a set of X such that X is in between 0 and 5. Now notice that X includes 0. So that's a bracket at 0. And then a parenthesis at 5. And then we want everything that's in between. Okay. Now we're going to answer 14, 15, and 16. So, and it's nice because notice how our number lines are lined up nicely. Okay, A intersect B. So this means I want what is common from set A and set B. So if we look at A and B, now B is open. That doesn't include negative 1, but A does include negative 1. So that's going to win out. Okay. So set notation is going to be X, or the set of X such that, now, since I want what is common from both sets, and what's common is going to be from negative 1 to 4. Okay, that's what's common. So negative 1, here's my X, and then the 4. Now I need to figure out what am I going to use. Now for when you have, this is called a 3-part inequality. So when you have this inequality, you want to make sure that the smaller numbers on the left, the larger numbers on the right, and your inequalities have to be less than or a less than or equal to. Now, remember at negative 1 for set A, it does include negative 1, B does not include -1, but this covers it. It picks it up. So that means this is going to be less than or equal to. And then at 4, well, A closes at 4 and B does exist at 4. So that's also going to be a less than or equal to. Okay. So that's our set notation. Interval notation is going to be just this. It's going to go from -1 to 4. So since both have the equal to, that means that it has a bracket. All right. And so this is our solution. I won't box it in because that's our answer. Okay. Now, A union B. This means I want everything. I want everything from set A and everything from set B. So notice that set A, we start at -infinity and we go all the way up to 4. And then set B starts at -1. And notice how set B goes past -4. Okay, so where this part doesn't exist, this does. So it covers this part up. This part doesn't exist, but this does. So it covers it up. So in other words, that means it's going to be all real numbers. So it's the set of all x such that x is all real numbers. And I'm going to abbreviate, put numbers. Okay. So that's our set notation. Now our interval notation, if it's the set of all real numbers, then that means it's going to go from -infinity to infinity. It's everything. So if you can imagine, if you pick this up and overlay it, okay, if you squish those two together, then you end up getting the entire number line. Okay. All right. Number 16 is A intersect C. So we only want what is common. So I'm looking at A and C. We're not looking at B. So what is common is, where do things begin? Well, C starts at 0, even though A goes beyond 0, but C starts at 0. And then A ends at 4, even though C goes to 5. 5 doesn't exist in set A. So the only part that's common is going to go from 0 to 4. So at 0, we have a bracket, and at 4, we have a bracket. So the set of all x such that, and then we're going to start at 0. Here's our x, and then we're going to go to 4. And since we have brackets, that means that they're both going to have less than or equal to's. So our interval notation is going to go from 0 to 4, but because we have the equal to, we use those brackets. Okay, that's how that works. All right, now, number 17 says find the union or intersection as indicated. Write your answer in interval notation. All right, so I'm going to color code these. All right, so for 17, we're going to go from -3 to 2. So at -3, we have a bracket, and we're going to go all the way to 2 with a parentheses. So it's all of this. Okay. All right. Now, the second part is -2 to 4. -2, we have a bracket. At 4, we have a bracket. So it's all of this. Now, I am asked to find the union. So I want everything from both sets. Okay. So if I want everything, well, the top one starts at -3. So I want it. Now this stops at 2, but the second set goes to 4 and I want it because I want everything. All right. So this is my solution. It's all of that. Okay. So that's my graphical answer. They want my answer in interval notation. So I'm going to pull my answer from this. So we start at -3 and it goes all the way to 4 and they both have brackets. Okay. So it's always easier to graph them individually, pull them together so that you can see what the graph is going to look like. All right. So let's do this again. So now this is going to go from -infinity up to 3 with the parentheses. So here's 3, -infinity. So it's all of this up to 3. Okay. Then we have the second set, 4 to infinity. So we're going to start at 4 with a parenthesis, and it's going towards infinity. It's going in that direction. Okay, now this is the intersection, so it wants what is common. So what is common with this set and this set? In other words, is there an overlap? And there is not an overlap, so I have no solution. All right, so I have nothing to graph. So my answer is just a no solution because I don't have anything. I don't have a number that works here and here. Okay. For the union, I can pick a number and it has to work here or here. Okay. And let me see. Did I write that down back over here? No, I need to stress this. This is very important. The union uses the compound word or. The intersection uses the compound word and. Okay. So that means that we need to have the union has to work either here or here. So if I were to pick a number, let's say 0, well, 0 is in between -3. It does exist here. It also exists here. So remember, it can exist in one of the sets or both. Now I can choose -3. Now -3 has to work here or here. -3 works here because of the bracket, but -3 does not work here, and that's okay because it's an or, so it has to work here or has to work in this set or in this set. So if I were to pick a number, let's say -2, the intersection says it has to work in this set and in this set. So if I were to choose -2, well, -2 is in this set, but it's not in this set because this set starts at 4. So it doesn't work here and here. It only works for 1. Okay, so that's why it's a no solution. Okay, last 2. I want you to try this on your own real quick. So I'm going to pause the video in 3, 2, 1. Okay, so 19 and 20, notice that they are, hope you noticed that they were the same. So my graphs are, the graphs are identical. They're going to be the same. This is the intersection and this is the union. So for the intersection, I want where they are common. And they are common from -1 to 3. So -1 to 3. Both have parentheses on either end. I made a mistake. This should be a bracket. Okay. Yeah, and I meant to put this in purple just to be consistent. Sorry. Okay. Oh, sorry. They're both brackets. It wants to know where they are common. Yeah, so -1 with the bracket up to 3 with the bracket. Okay. Yeah. All right. So that's it. That's where they both exist. Okay, now for the union is everything. It's greedy. It wants it all. Okay. So I want all of this, and I also want all of this. So here's from -3 as it goes towards negative infinity, and then from -1 as it goes towards positive infinity. So that's the entire number line. So that's all real numbers. So this is, again, I'm just going to put this in purple to be consistent. So this is going to be negative infinity to positive infinity. Okay, that's it. So that's the review. All right, let me know if you have any questions. I think that's it. Hang on a second. Yep, that's it. All right, guys. So if you have any questions, let me know.